Hello friends, today I am going to discuss the principle of superposition acting on the body. It means when more than one force is acting on a body, then there is a change in length on each section is a different, and this total change in length is the algebraic sum of all the sections. That means we are going to discuss with the examples. First we will see the definition of it. The principle of superposition says that when a number of loads are acting on a body, the resulting strain, according to the principle of superposition, will be the algebraic sum of strains caused by individual loads. It means याचा अर्थ असा असतो की कोणत्याही बॉडीवरती एक पेक्षा अधिक फोर्सेस ऍक्ट झाले तर प्रत्येक सेक्शन वरती डिफरंट स्ट्रेस येतो, डिफरंट स्ट्रेन येतो आणि टोटल स्ट्रेन जो असतो तो टोटल स्ट्रेन काय असेल अल्जेब्रिक सम ऑफ ऑल दी स्ट्रेन्स ऑन ईच सेक्शन कॉज्ड बाय इंडिव्हिज्युअल लोड्स. म्हणजेच काय प्रत्येक सेक्शनचा आपल्याला सेपरेटली स्ट्रेन कॅल्क्युलेट करून तो ऍड करावा लागेल. जर टेन्साईल लोड असेल तर तो पॉझिटिव्ह घ्यायचा, जर कॉम्प्रेसिव्ह असेल तर तो निगेटिव्ह घ्यायचा. आपण साइन कन्व्हेन्शन मध्ये ते बघितलेलं आहे. इफ लोड इज अ टेन्साईल then change in length is a positive. If load is a compressive, then the change in length is a negative. When an elastic body is subjected to number of tensile or compressive forces at different sections, then the following procedure is adopted to calculate stress, strain and change in length in each section. Means if number of forces acting on a body, these forces are tensile or compressive, then following steps are adopted to find out the total stress in that body, strain in that body and change in length in that body. First step is draw a free body diagram of individual section. Means we have to draw free body diagram of each section and calculate load acting on each section. Second step is calculate stress, strain and deformation in each section. Means we have studied the formula equation of stress is a force upon area. On that equation we are going to calculate the stress, strain, that is change in length upon original length we are going to calculate, and deformation means PL upon AE. This is the formula. In each section we will get different stress, different strain and different deformation due to loads are different on each section. Finally, calculate algebraic sum of each section to get total deformation of the body. Means we have to do algebraic sum of all the sections. That means strains we are get. We have to do algebraic sum. If tensile strain is there, then it is considered as a positive. If compressive it is considered as a negative. And let us discuss with the problems, then we will understand better than this. Problems are very simple. These are similar to basic problems we are discussed in the last lecture. Only difference is we have to do total change in length, summation of all these forces, and loads are only different at every section. A circular bar having 200 mm square area is subjected to axial loads as shown in figure. Find the value of P and the total elongation. Take E is equal to 2 into 10 raised to 5 Newton per millimeter square. Here is the diagram. 50 kilonewton on the left hand side, 50 kilonewton on the right hand side load is acting. P and 20 kilonewton are on the middle section of the object. Length of AB is 1 meter, BC is also 1 meter and CD is also 1 meter. And cross sectional area is given. A is equal to 200 millimeter square. Young's modulus E is equal to given 2 into 10 raised to 5 Newton per millimeter square. And first question is find the value of P. Means we have to first calculate the value of P. For calculating value of P, we have to do summation of all horizontal forces because there is no vertical force. But all horizontal forces means P is the horizontal force, 20 is towards left, 50 is also towards left, and this P is the towards right and this 50 is towards right. Means towards right are considered as a positive and towards left are considered as a negative sign. Let us find out the value of P doing summation of fx. Now here is the to find value of P for equilibrium entire bar, fx is equal to 0 and fx is equal to minus 50 towards left, minus 20 towards left. This is a value of P towards right positive, and this is also P towards right. 50-50 get cancelled because plus and minus, and P is equal to, we will get 20 kilonewton, that is towards right. Then value of P is equal to 20 kilonewton. We find out the value of P, and next is we find out the loads acting on each section. Here is the first section AB. Consider only towards section 1-1. Only 50 kilonewton load is acting towards left side of A. Then for equilibrium condition, 50 kilonewton is acting on towards right. Therefore, load P1 is equal to 50 kilonewton acting on the first section. Similarly, we have to do for second section, section 2-2. Consider on the left hand side or right hand side of section. We are going to consider on the left hand side. That means this is the section total. 50 kilonewton towards the left and 20 kilonewton towards the right. Means plus 30 kilonewton towards the left is the extra load over here. That will be applied at point B. This is the 30 kilonewton load. That is P2 is equal to 30. That means for equilibrium condition here we have to apply 30 kilonewton. And if you consider section 3-3, only 50 kilonewton is present on right side, apply 50 kilonewton, and for equilibrium condition on left hand side also we have to apply 50 kilonewton load for equilibrium condition. This is the free body diagram of each section. We have to calculate loads acting on each section in such a way. Now calculate change in length for first section, second section and third section. All loads acting on each section are tensile. Consider tension as a positive and compressive as a negative. dl is equal to total change in length is equal to delta L1 plus delta L2 plus delta L3 by principle of superposition. Formula of dl is equal to PL upon AE. P means load acting on first section, L means load acting on first section, length of first section. That means P1 L1. P2 L2 means load acting on second section on length of second section. P3 L3 means load on third section, and L3 means length of third section. AE is the common because cross sectional area is same and material is also same. That means 1 upon AE gets common, and P1 L1 plus P2 L2 plus P3 L3. Put all the values in that equation. We will get delta L is equal to 3.25 millimeter. Therefore, total elongation of bar is the 3.25 millimeter. Positive value delta indicates increase in length because all the forces are tensile forces. It indicates total change in length is the positive value. That means increase in length. Second problem. Second problem is a similar problem is there. A steel bar of 800 millimeter square cross sectional area. Area is given 800 millimeter square. Is subjected to axial forces as shown in figure 50, 80, 20, 10 kilonewton. Find the total change in length of a bar if E is equal to 2 into 10 raised to 5. Means Young's modulus is given 2 into 10 raised to 5, and length of first section is 1.5 meter, that is 1500 millimeter. Second section BC is 3000 millimeter and CD is 1500 millimeter. There is not any unknown force given. Any unknown force given. That means P is not given. Directly 80 kilonewton value is given. म्हणजेच आपल्याला डायरेक्टली याच्यामध्ये काय करावं लागेल, प्रत्येक सेक्शन वरचा लोड कॅल्क्युलेट करावा लागेल. आता तो कसा करायचा पुढे आपण चेक करूया. सिमिलर वे आहे. फर्स्ट काय सेक्शन 1-1 ऍट सेक्शन आणि BB 1-1 सेक्शन हे घेतलेलं आहे. On the left hand side of section 1-1 only 50 kilonewton load is acting. That means for part 1 section 1-1 only 50 kilonewton tensile load is applied. For equilibrium condition, this P1 is equal to 50, P1 is equal to 50. This is 1. And for second section, 2 section is taken and check. This is a 50 towards left and 80 towards right. Means plus 30 is there on right hand side. Means 30 kilonewton load is acting on this section BC. Why? Do the addition of these two forces by considering sign conventions. 50 minus 80 plus means 80 minus 50 is 30. Therefore section BC is acting section BC वरती 30 kilonewton compressive force act होतोय. P2 is equal to 30 kilonewton. Therefore for equilibrium condition here also we have to apply 30 kilonewton load. सेक्शन 3 कुठलाही एक सेक्शन या राईट हँड साइडचा किंवा लेफ्ट हँड साइडचा तुम्हाला मिळेल. सोपं काय पडतो तर राईट हँड साइडला सोपं पडतो, इझी जातो. राईट हँड साइडला 10 किलोन्यूटन आहे, कॉम्प्रेसिव्ह लोड आहे, म्हणून इकडे आपल्याला पण काय करावं लागेल 10 किलोन्यूटन अप्लाय करावं लागेल इक्विलिब्रियम कंडिशन साठी. CD is acted by 10 kilonewton compressive load. Here is the P1 50, P2 30 and P3 is the 10 kilonewton load. And calculate the total change in length each section and sum it. Delta L1 is delta L is equal to delta L1 plus delta L2 plus delta L3. Again, tension as a positive and compressive as a negative. AE is get common P1 L1 plus P2 L2 plus P3 L3. Put the value of AE 50 into 10 raised to 3. This is the tensile force taken as a positive. 1500 is the length plus minus 30 means this is a compressive load and this is the length, and minus 10 this is again a compressive load. And after doing this calculations we will get delta L is equal to minus 0.1875 millimeter. Negative sign indicates a decrease in length. That means there are two compressive loads acting on the two sections and one tensile on one section. One body gets elongated and two body gets compressed, and total algebraic sum is the negative. That means negative sign indicates overall there is a decrease in length of section A, B, C, D. Problem number 3. Similar problem is there, but there is only difference is the cross sectional area. A member ABCD is subjected to loads as shown in figure. 120 kilonewton, 220 kilonewton, and this is the load P. We have to calculate unknown load P, and this is the 160 kilonewton. Find the force P and net change in length of the member. Take E is equal to 2 into 10 raised to 5 Newton per millimeter square. First area is the 40 into 40 millimeter square. Second area is the 20 into 20, and third is the 30 into 30 millimeter square. What is given first? A1 40 by 40, that is 1600 millimeter square. A2 is equal to 400 millimeter square and A3 is equal to 900 millimeter square. L1 is equal to 1000, L2 is also 1000 and L3 is 1500. To find out the values of E, we have to do summation of all horizontal forces and minus 120, this is left, that is means negative, plus 20 towards right, positive, minus P towards left, negative, plus 160 towards right. Overall value of P is equal to plus 260 means positive. We will get positive sign means given direction is incorrect, means in problem direction is shown towards the left. That means आपला आन्सर निगेटिव्ह आला पाहिजे होतं, पण तो पॉझिटिव्ह आलेला आहे. म्हणजे त्यांनी जे डायरेक्शन दिलेलं आहे ते पूर्णपणे चुकीचं आहे. आपल्याला तो डायरेक्शन चेंज करून टुवर्ड्स राईट घ्यावा लागेल. Next, take section along 1 This is the 120 kilonewton. Apply directly 120 kilonewton on left and right of a section 1 that is section AB. P1 is equal to 120 120. At section 2 120 towards left, 220 towards right. Means plus 100 towards right. 100 is the compressive load on section 2 and 160 towards right. Here again we have to apply 160 kilonewton. That means first section is acting by tensile load of 120, second body is acting by compressive of 100 kilonewton, and third body is acting by tensile of 160 kilonewton. And now also again we have to do summation of all the change in length. Delta L is equal to delta L1 plus delta L2 plus delta L3. Here only E is the common because material is constant, area is changing, and it's E will not A will not get common. 1 upon E is equal to P1 L1 upon A1 plus P2 L2 upon A2 plus P3 L3 upon A3. Tensile stresses, tensile loads are put as a positive and compressive loads are put as a negative. And that is the total change in length is the 0.458 millimeter. That means it indicates there is an increase in length. Thank you.